very much. Hello, everyone, and welcome. My goal today is to introduce you to a new open source library that enables you to automatically test and certify that NLP models, like for example, like large language models, are actually fair, reliable, safe, and effective. Going back to the presentation we just heard from Kavri, one of the questions was, should tools be certified? How do you make sure that tools are actually, robust, correct, unbiased? This is something that definitely needs to be done on a regulatory level. But there's also a question of how you do this on a day-to-day level as a technologist, which is what I hope to be able to help you with today. So first thing to know is that responsible AI is not optional without waiting for any additional legislation or regulation. Right now, if you are deploying or selling or making public models that are biased, that are opaque, that are unreliable in some way, you may already be breaking the law. Whether you're doing things for consumer goods or for HR and recruiting, and definitely if you're doing things in the medical space, right, whether clinical or biomedical, right, or safety related. Because right now, especially in healthcare and life science, we are already required to make sure that our tools are at the very least safe and effective, right, and definitely to the extent possible unbiased. And I can tell you, I work at Johnson Labs. We are already signed on contracts where because our customers, who are pharma companies, healthcare systems, are required to do this as well. We need to prove that our models are actually working in an ethical way, in a reliable manner. So what do companies do when they hear the public outcry and regulatory pushback around responsible AI? They build frameworks, right? And those frameworks are kind of, they have these nice visuals and they look like this, and they say, look, our AI is responsible and it's very ethical and it's very human-centric and it's very societal based, and they explain that they have this very holistic view around how models work in society. And there are a lot of these, right? So there's not just one of them, there's quite a few of them, and really we got to a point where every large company, whether it's a technology company or consulting company, published with great fanfare the responsible AI framework to make sure that yes, they actually look at all of those things and care about all of those things. But then the question came, okay, so these are the goals and these are the ambitions, but what do you actually do? And right now, what companies said is, okay, look, we'll have compliance frameworks. And what does it mean? It means that we look at we look during the entire project, from the inception of the project, right? Well, one of the things you have to think about are the ethical considerations of the new project you're proposing. During the project, we look at how you test it. We before you go to production, we check. We ask you if you're actually tested, right, for bias representation, those kind of things. And that's basically it at this point, right? So many companies do this, but it comes down to, yes, in our project template, we added the section, right, where we have to discuss the ethical limitations, right? And a lot of the current, model hubs or academic papers deal with that. But as people who are actually building those things, that still leaves us with a very, very big gap, because the models that are actually being delivered and actually being deployed right now are honestly pretty horrible in the kind of really in where they stand on some like really basic reliability, bias and fairness metrics. So one very well-known paper is from the checklist paper from 2020 that looked at the sentiment analysis models that are used by the public commercial APIs of AWS, Azure, and Google Cloud, and look for really just basic robustness tests, and found that the models were highly unreliable with small changes. So, for example, if instead of saying I'm flying to Dallas tomorrow, which is a neutral sentiment, you said I'm flying to New York, in between 7 and 20% of the times that would actually change the sentiment. If you would do things like negation, I did not think that flight was horrible, right? Which should be neutral. Most of the time, so between half and 2/3 of the time, the commercial model would get it wrong. If you look at some types of temporal tests, so, I used to think this airline was really bad, but now I like it. Almost always the commercial models would fail. And really there were all these really basic reliability tests that show that really on things that are supposed to be commercial production, all of that, we're getting horrible responses. There are more recent papers looking at specifically at biases, showing that within current question answering, kind of prompt-based question answering models, answers can change up to 80% of the time. When you say, instead of what happened to this person, you say what happened to this rich person, poor person, what happened to this gay person versus straight person, what happened to this Christian person versus Muslim person. And people look at kind of 16 categories of basically non-societal stereotypes, and found that really just adding a mention can cause problems. Like in healthcare, one of the recent papers shows that when you do risk stratification, just adding any mention of ethnicity, white, black, Hispanic, Asian, doesn't matter, reduces the perceived risk score of the patient. And there are also issues around data leakage, right? So basically PHI leaking into models. So there's a whole lot of gap between kind of the principles and the framework and really what's actually happening. And when we were working, our goal is to come and say, okay, look, let's see what we've learned, and can we do something for the open source community to help close that gap. As we did it, there are three main principles that are kind of very well known, very well understood in software engineering that are applicable here. The first and really simplest and most important is to actually test your models. And if you've done any work in software engineering, this should make you laugh, because it should be obvious, right? It should be, look, yeah, why would software that you never tested, why would you expect it to work, right? Why would you just deploy something without ever testing it and expect it to work in different conditions, right? In edge cases, right? For specific subpopulations. But the point is, today, most people don't, right? You take a model, you optimize it, you do hyperparameter tuning, you get to the best F1 score you can, or whatever your accuracy metric is, and you deploy. So one thing we would want is we want to be able to test models really holistically across all the things, all the aspects we care about. The second thing we've learned is that you should never ever take models that were published really as part of academic papers, kind of academic models, and just put them in production. So this is very popular today. People publish their models on PyTorch Hub, on Hugging Face Hub, right? On those kind of really it's part of showing your work as an academic. And then people assume, oh, okay, look, there's this model, it can do hate news detection in Turkish. I'm going to just use it. Those models in general, what we found is a very big gap between what they do on academic test set and what they do on kind of really those other aspects of reliability, robustness, fairness, bias, leakage, and so on. And also in general, if you take the learning from software engineering, there's a very big gap between here's prototype code that does something and here's production grade code that you'd actually want to deploy. The third important principle is that you really need to test beyond accuracy. So of course, you want your model to be as accurate as possible, but there are probably between 5 and 10 other aspects of the model that you need to test before you're able to go into production. So to enable you to do that, I'm able to introduce a new open source Python library, which is the nlptest library, which is developed over the past year with a number of organizations in order to have something that's free, open source to the community that you can use right now to make this, to apply this principle and best practices in your own work. So going from right to left here, first of all, it's open source under the Apache 2.0 license. So everything I'm showing you today is completely free with everything, including for commercial use. The second thing, the goal is to be a comprehensive framework. So the goal is really to have one test suite that you can generate and run that enables you to test really all the aspects of a model, of an NLP model that should be tested before you're ready to go into production. And the third important thing is simplicity. So right now there are more than 50 test types of different different types of tests that we can automatically generate. The cool thing is, compared to the unit test frameworks of old, we have generative AI now. We can very often automatically generate tests, and you'll see some examples, and of course we can run them, which really makes things very simple for you to take and apply. The NLP test library is looking to automate 3 steps in your data science workflow. So instead of going from training a model to releasing a model, right? It's going to say, look, yeah, I trained it, I optimized it, the F-score is good, I did my validation, it's ready to go. we need to add 3 steps. One is we generate test cases. Okay, so we generate test case to look at robustness, to look at bias, to look at accuracy, right, to look at fairness, to look at representations, to look at other things. And you can generate automatically, you can generate manually, you can have a mix of both. Then you automatically run the tests. And then you configured what you consider a passing grade for each category. And then if the tests pass, then great, you can deploy. If the tests do not pass, then there's one other thing that we can do for you automatically, which is we can automatically generate augmented test data. Augmented training data, so that you can go and retrain the model. Okay, so for example, if your model does very poorly on, when the names of people, for example, are, Hindu, okay, because honestly it was just not in the training data. So we can take your data and we can add, we can generate additional examples, right, that are basically variants of the training data that you have with those kind of names, add it to your training data set so that you can retrain the model and test it again. So those are the 3 things that the NLP test library aims to do. In terms of how to use it, here's the kind of the simple basic workflow. It's really simple. It's a Python library, so pip install nlptest, and then from nlptest import harness. Harness represents a test harness. So when you create a test harness, in this case, we're testing right what is today the most popular model on Hugging Face, or the BERT-based NER. We load that model. So we say, okay, the task is name and recognition. Here is the model we are testing. And then we call 3 methods on the harness. So we call generate. Generate basically generates a set of test cases automatically, given the task that you have, the model you have, and the test data set that you have. And that creates basically a pandas data frame with the test cases that are available within the harness object. Then you call run. Run, as the name suggests, actually runs the tests. Okay, so now we have a set of name and recognition test cases that we have, and now we actually run them and we see whether they pass or fail. And then we can call report, which groups the test results by category and basically tells us whether we passed or failed the whole test, right, or per category. One very important thing that we want to make sure happens with the library is that you can write the test once, and then we want to be able to test really all the major libraries and all the major APIs. So right now there is out-of-the-box support for any Johnson Labs models, Hugging Face models, and Spacey models, and the library works seamlessly across all of them. And this was a very important design principle. So if you are working with this framework, if you're adding a new test type, for example, you're adding a new type of, say, PHI detection or data leakage test, then once you've coded the test will be available across all libraries. Also, if you're adding a new library, so for example, one thing we are working on right now is to be able to test directly, for example, the ChatGPT API, or you may have your own, llama-based large language models that you have trained. You need to implement one interface, a class, and once you've implemented that, all the test types, including generation, running, reporting, will work with your new library. Okay, so we wanted to make it very reusable and very easy to expand as time goes by. So in terms of the 3 tasks that the library helps you automate, the first one is generating tests. And there are different types of tests that we can generate. The first kind of test is robustness tests. For example, you have test types that can add typos, change punctuations, change capitalization, so change everything to uppercase, lowercase, change the entities that you're looking for, right? So change like people's name, location, products, works of art. Basically to see if an entity recognition, right, or text classification task still work. Okay, so is the model robust to misspelling, to changing, for example, from male to female pronouns, from present to past conjugations, and so on. A certain type of test is on fairness. You can define that, for example, the accuracy for the F1 score for males and the has to be at least as such. The accuracy for females has to be at least such. The accuracy for people with unknown gender has to be at least at that level. To make sure that your model does not perform differently across different genders. And you can do this for genders, you can do this for age groups, right, and the other dimensions. There are coverage tests where you can look at really just different types of sports, products, people, places, organizations. There are different kinds of biases that you can check. As you can see here, nationality bias, age bias, ethnicity bias. There are different types of changes we can make to people's names. So predominantly kind of white names, predominantly black names, predominantly Hispanic names, predominantly Asian names, predominantly Muslim names, predominantly Buddhist names, Hindu names, and so on, based on kind of public government lists of prominent names of those ethnicities. In terms of origins, there's a split between kind of high-income countries, mid-income countries, low-income countries. So whenever you mention a country, you can basically have other tests that test that your models work across the gamut. Of course, there are accuracy metrics. One of the things you want to test before you deploy a model is, yes, just the classic, is the F-score at a certain point. And you can also look at representation. So one of the issues that we see often, for example, with gender or age group, is that we cannot even calculate an F1 score for for children, for people under 18 years old, because there's only 5 of them in the test set, right? So sometimes you have groups that are completely underrepresented, right? And so you want to fix representation before you can even talk about what the F1 score, right, and accuracy for those groups. So those are just kind of the tests that are there. As you can see, the goal is really to be comprehensive, to get to a point where if you pass something, you feel confident that your model is stable across the across the spectrum. And also you should feel confident going to a regulator and come and say, oh, you want to see how I tested fairness and robustness? Here's a list, and it's a human readable list of 500 tests. Here's how I do it. Here's the methodology behind it, right? Here are the papers. If you don't believe me that the model actually passes this, good for you, run it yourself, right? The library is there, all of this is executable. So once you generate a test, you want to run them. A set of tests, a test suite looks something like this. So you have a test type. So here, for example, the first one is, add typos. We have the test case. So here, Wongley is a doctor, right? So we added the spelling mistakes. Instead of doctor, it says doctor. But we still expect, for example, a name entity recognition model to say, oh, Wongley is a person, right? And you should be able to extract that, right? Similarly, we can add context. We can replace names to Hispanic names. We can require a minimum representation of the female gender, right? And in this case, also a minimum F1 score for the gender, the female gender, right? But in general, you can have many, many tests, right? That either you put in manually or were generated. Once you call run, it runs the tests. And then what report does, it categorizes the test by category. And then it compares the pass rate of each category to the minimum pass rate that you've configured. So, for example, you can look at all robustness tests and come say, look, only half of your robustness tests passed, right? So you had a 50% pass rate in this specific test suite. You yourself set the minimum to 75%, so you have a fail here, right? And here on bias and representation, you did okay, but also on fairness, you did not reach basically your own standard. So you can configure the minimum pass rate, but the point is, once you hit report, you get this kind of report. You can see per category whatever passed. And then you can decide, right? And usually the standard is the model has to pass across in each category, right? So that you deem it basically production ready. The third capability that you have is data augmentation. Okay, so for example, let's say that we found that the model performs really poorly on Hispanic names. Okay, so for example, if you look at the example here, so we have Wongley as a doctor, but if we change it to Juan Moreno as a doctor, okay, or in general, when we had, say, 30, 40, 50 examples of Hispanic names, accuracy is lower. So one of the ways to fix it is come say, oh, look, you need to add those examples to the training set, right? And the way you do it is basically very similar to what we did with tests, because we can generate those examples automatically, right, with the labels that we expect. So that would be interesting to add with the training data. The only difference is that we cannot, of course, use the test suite, because that would be a classic case of data leakage, right? So you cannot go and retrain your model with what you're going to test it on, because, of course, it's going to perform better because you're training it on the test data. So what you have here, you have the method augment. So if you have a harness, you can call age.augment. But what you give it as an input is not your test dataset, but a training dataset. And what it does, it looks at the training data and it generates variance not from the test set, but from the training dataset, right, which is separate. and it knows which variants to generate because it knows where your model is doing poorly. That's the point of having a harness. And then it outputs an augmented training dataset. So now you're augmenting your training datasets, right, without polluting it with any test results. The next thing you do is you retrain the model, and then of course you do outside the NLP test, you do it with whatever training library you care to use. And once it's there, what you want to do is run a regression test. Okay, so a regression test basically means I have a new model, but I want to run it with a previously saved test suite, right? So I call harness.load, and I have the save directory. So from the directory, I load the test cases that I had before, the same configuration. And the only thing I want to change is the model, right? So the save dir is the test dir, that's where my tests are, but the model is the new model. So basically, what I tell it is, look, use the same tests as you had before, but now on this new model. And now when you run it, you'll see basically how your model performs, right? How your new model performs against the previous test set. So that's the workflow for data augmentation. And really what we are seeing is that really with some of the most widely used models, just doing that can substantially improve how a robust, reliable, or fair a model can be. And one of the things we're working on now is to start to publish basically more robust and fair models for some of the most widely used open source tasks. The last thing that you'd want to do is you'd want to be able to integrate this kind of testing in your CI/CD workflow or in your MLOps workflow. We want to be able to integrate with different MLOps tools, right? Whether using Jenkins or SageMaker, right? Or MLflow, whatever may be the case. But the workflow in all cases, really, it's pretty simple. You train a new version of the model. Before you deploy it, you run a regression test. Okay, so you have a step that says really the same thing you do with unit tests or integration testing on software. You kind of say, okay, you have a new model, cool. Load the new model, load a pre-built set of tests, run those tests. After you call report, basically you know whether you have a pass or a fail, right? With the minimum criteria that you have set. And then you can decide, right? If you pass the test, then you deploy the new version. If the test fail, the test fail, right? It's the same thing as if your unit test fail, right? And you need to notify the developer that yes, this model will not be going to production, right? And the cool thing is those regression tests their files, so they can be versioned, can be human readable, and really just like you do with software, right? You can be at the point where because it's part of your process, then anything you've released actually passed this set of tests, right? And this is something you can show your users, something you can show a regulator, right? And something your development team knows, right? Where look, wherever we have a feedback loop, we do something, we'll have something that will tell us if we break something, right? So if we have a feedback loop, we have feedback from lots of users, but those users, they happen to be all female. So now actually our accuracy for male is dropping. Okay, the test will fail. We'll know what we need to do. We can augment the data and then release a model that still kind of abides by our own standards. So that's what I wanted to present. The NLP test library is live and available to you now. So the GitHub is github.com/johnsonlabs/NLPtest. You're welcome to fork, use the library. Other than that, to use it, really just pip install NLP test and you're off to the races. If you're looking for tutorial and examples, also this is an open source community website, and it's a collaboration of quite a few people. So nlptest.org is the website for the community. And if you're looking to take part or contribute, so definitely you're welcome to reach out via GitHub, right? Open issues, discussions. Or if you just want to do a chat, there's also within slacknlp.slack.com, there's now a dedicated channel for NLP test, and the development team is there, and we're happy to support you as you're starting to use it with any questions that come up.